going to introduce ISELED, the smart RGB LED driving technology. Let's take a look at this video first.
ISELED is a technology which is going to revolutionize the use of RGB LEDs. Innova Semiconductors and other companies formed an open alliance to build the necessary ecosystem and establish the technology in the market. ISELED puts a smart RGB LED controller inside the LED itself. Each LED module contains its calibration data, resulting in a significant system cost reduction. Up to 4,096 LEDs can be daisy-chained and fully controlled by a bidirectional differential bus. Built-in diagnostic capabilities support the use in functional safety applications. Innova Semiconductors and the Open Alliance partners provide the necessary tools and demonstration kits to get familiar with the ISELED technology. ISELED, revolutionary technology for ambient light applications in automotive.
Here on this graph, what we can see is how RGB LEDs are currently being used on cars. Every 1 to 5 LED modules are controlled by a subcontroller. Car makers would waste a huge amount of money and effort to facilitate such a design because of copious cables and connectors needed. To ensure each LED module can remain a stable optical performance, these LED modules need to be calibrated individually, which costs engineers from both car makers and Tier 1s much time and effort. Additionally, there's only one-way signal communication between the LEDs and subcontrollers, and they are usually delayed. If we ever try to accelerate the transmission speed, there will be serious EMI problems that prevent the system of effectively carry our diagnostic features. Now, let's see how ISELED by Innova tackled these difficulties. ISELED technology transforms each subcontroller into a small LED driving chip and embeds them into each LED module. Meanwhile, car makers and Tier 1s no longer need to spend resources to figure out calibration, as calibrations will have already been done when building the LED module. Therefore, a new form of RGB LED modules, including a 3x4mm packaged IC, largely reducing the wiring and cabling requirements and thus reducing costs. Whereas car makers need to do the calibration by themselves, they can now leave the work to LED manufacturers, as LED manufacturers will already have completed calibration when building the LED modules. Communications between MCU and smart LED modules are also bidirectional. We keep a 2 MB per second bandwidth to ensure superb EMI performance and signal diagnostic feedback. MCU now can detect the temperature or aging conditioning of each LED module by their individual unique address. From an application perspective, ISELED was first proposed by German car makers to address the need for automotive interior lighting. With the growing publicity of ISELED technology, more and more people, others than the automotive industry, also noticed the values of ISELED technology. Potential area of applications include, but are not limited to, aerospace, marine, or any kinds of exterior lighting, such as those used on large billboard or skyscraper exteriors. In the future, ISELED can also work with various sorts of ADAS systems and more, such as automotive driving, manless car, and functional lighting. Each set of ISELED can daisy-chain up to 4,096 LED modules. There are also panel manufacturers now studying using ISELED on display backlight control. With such superb technology, Innova Semiconductors, together with major players in the industry, formed the ISELED Open Alliance. As of May 2019, there are 22 members, including initial members of Innova Semiconductors, the Display Lab of the University of Pforzheim, NXP, as well as system integrators such as TE, Valeo, Melexis, and LED manufacturers such as Osram Opto and Brightex. To put it simple, members of the ISELED Open Alliance are all contributed partners along the smart RGB LED supply chain. Innova Semiconductors developed the core of the ISELED technology, which is the control bare die, and pass on these dies to LED manufacturers such as Brightex. System control suppliers such as NXP and Microchip will then design an ISELED-compatible MCU for users to easily drive the ISELED-embedded LEDs. Thanks to the ISELED technology, Tier 1 customers will now source MCUs and the already calibrated LEDs from ISELED partners. They can spare the effort to work through the complicated calibration and binning and sorting process while providing dynamic color effects comprising million kinds of colors for their OEM customers to use. For example, using ISELED for the interior lighting can save your system's control costs. Car makers now no longer need to calibrate the color and temperature of the smart LEDs by themselves. When the LED manufacturer built the LEDs, each module has already been calibrated. Bidirectionality also allows the car makers greater flexibility in design. Error and deterioration diagnostics are also introduced into the use of smart RGB LEDs for the very first time. Thanks to its unique bidirectional communication, ISELED can be used together with telltales on the clusters to supplement ADAS applications. You can even use ISELED for functional lighting, such as the forward collision warning, lane departure warning, and driver drowsiness detection. Any kinds of functional lightnings with millions of color features that can warn drivers to be aware of the street. Like previously mentioned, one single ISELED controller can drive up to 4,096 LED modules. A handful of panel manufacturers are also studying the possibility of using ISELED for panel matrix backlight. There is a package INLC 100Q16 chip that complements ISELED applications. Customers may choose a controller chip INLC 100Q16 to complete the single-ended communications, connected to a string of ISELED embedded RGB LED light chains to daisy chain up to 4,096 light modules. Should a customer choose not to work with ISELED embedded RGB LED modules, it is also possible to use multiple INLC 100Q16 chips to drive RGB LED modules of their choice. INLC 100Q16 even has other applications, such as a fourth parameter to control the white light, as some customers may have higher requirements for color accuracy. Customers may now use INLC 100Q16 to control the four parameters of R, G, B, and W. In conclusion, the smart RGB LED control technology of ISELED can individually address each LED module on a light chain, providing the customers an easier way to calibrate and drive the LED module they were never able to. Since calibration data will have already been stored in the LED module when being produced by the LED manufacturer, customers are now able to enjoy numerous features, including but not limited to bidirectional communication and diagnostics such as color and temperature compensation, and many more.